Hello, here is another problem on work done, right? These work done problems are kind of tricky because they involve rate. And yeah, you need to really visualize and understand the problem very well to get it right. So this is a good time to understand the strategy behind. The question is, Tom needs 40 minutes to plow a field. Ellen can do in 30 minutes the same job. If Tom works alone for 10 minutes and then Ellen joins in, how long will it take for them to complete the job? Well, the problem is kind of tricky because in normal examples, we see both working together right from the very beginning, correct? Now here, one person is working for 10 minutes and then both start working together. So that makes our problem slightly tricky, right? So plow a field, let's say the field is like one big job, correct? So what happened is, let's say this is one full field here. Let me just kind of sketch it out for you a bit. Now Tom needs 40 minutes to plow the field and Ellen can do it in 30 minutes. If Tom works alone for 10 minutes, so in 40 minutes he can do the whole job, right? But he's working alone for 10 minutes, so how much job will he do? So this is like half. He will 40 minutes all job, half means 20 minutes, and 10 minutes means 1/4 of the job has been done by Tom alone. Do you understand that part? Think about it again. Now before Ellen joins in, that means Tom has already worked for 10 minutes to complete this job as a whole, right? So by the time Ellen joins it, 1/4 of the job has been done because he has worked for 10 minutes. If he works for 40 minutes, full job can be completed, correct? Now, so in 20 minutes, half job will be completed, and in 40 minutes, 1/4 of the job will be completed, correct? Another way of looking into it is like this. So how much work will Tom do in 10 minutes? So we say in 10 minutes, Tom will do how much of the job? Tom completes in 1 minute he does 1/40, right? 10 times 1/40, which is 1/4 of the job. Do you see that? Because in 40 minutes all the job is done. In 1 minute 1/40. In 10 minutes 10 times 1/40, which is 1/4, which you should clearly see from here also, right? So how much of the job is left? So the left job is 3/4. Do you understand? 3/4 of the job is left. So let me make another table for you to understand this situation. I'm just trying to give you different options, okay? So you can take the one which you understand best. Yeah? Okay, let's think like this, that these are the two persons, Tom and Ellen, correct? And the quantity of job, let's say job as a whole, let's call it 1 unit, one full, right? Correct? Now, what Tom does is alone, he does 1/4. So both will do how much of the job? Both are doing 3/4 of the job. Do you see that? Not full job. Is that okay? Now, second thing, at what rate do they work? Rate is 1/40, because see, time, how much time do they take? Time takes 40 minutes to do, and let me say 40 minutes. I don't have to write minutes here, but anyway, 40 minutes and 30 minutes. It takes 40 minutes means longer, right? So the rate is slower. The rate is 1/40. Do you see that? And for Ellen, the rate is 1/30. Do you understand? This is the total rate of this. So when they work both, they are not really doing full job, but the total time taken will be 1/t of 3/4, right? So I'll write 3/4 over t is the total job. Let's say t is the time taken. So if the t is the time taken, then 1/t is the rate. And how much job are they doing? Not the whole job together. 3/4 of the job they are being together, right? So that's another way of looking into the same problem. So this leads to our equation that when they work together, then what? Alone Tom has already completed 1/4 of the job, so they are left with 3/4 of the job, right? When they work together, then the equation is 1/40 is the speed with which Tom works, plus 1/30 is the rate at which Ellen works, right? And they do the job in t second or t minutes. So t minutes is 1/t. And how much of the job they do? They don't do one full job. They only do 3/4 of the job. Do you understand? So that is how we get our equation. Take a moment to understand this equation. Okay. Now, the part is we got to simplify this. And to simplify this, we should find the common denominator. The common denominator, least common denominator is 30 times 40 is 120 and then t, right? So we'll multiply each side by 120t, correct? And solve it. So if I multiply this by 120t, basically I should multiply this by 30 and t, right? Is that okay? So let me do it. Let me write this statement here as 120t times 1/40 plus 1/30 is equal to 1/t times 3/4 times 120t. Is it okay? We multiplied both sides by 120t, correct? Now if you open the bracket, correct, these are good steps to write and to understand slowly, but it's kind of complicated, right? So to multiply this, 120 divided by 40 is 0, 0 cancels, 12 divided by this is 3, right? So you're left with 3t here, 3t plus here 4t, right? 4 times t equals to, this t gets cancelled with here. If you want, I can do it for you, correct? And this 4 will go how many times? 30 times, correct? So 3 times 30 is 90, right? So you're left with 90 here, correct? 3 plus 4 is 7, so we get 7t equals to 90. So time taken is 90/7 minutes. Is that okay? So that is the time taken for them to work, okay? So you can write it in fractions, but anyway, it is 90/7, or this goes 12 times and then we get 12, 6/7 minutes, okay? Anyway, so that's the time taken. So therefore, how long will it take for them to complete the job? So they will take, answer, you can write it like this, both they will take 90/7 minutes to complete the job. Okay, I hope you understand the method and the way we approach this problem. Okay, thank you.